Lesson 11, I will solve problems using a symbol for the unknown angle measure. So in Lesson 10, we started learning how we could solve for problems without using a protractor if we knew part of two adjacent angles or two angles that were side by side. Well, today we're going to continue to expand on that. If you'll think back to yesterday, or it may have been today, I don't know, but if you think back to Lesson 10, the big idea here was if you had two angles, and it was either a straight angle like this, made up of two parts, and we knew that if we took angle A and we added it to angle B, they had to equal what? If this is angle A and this is angle B, if this is a straight angle, A plus B had to be equal to 180 degrees because this is a straight angle. And we did the exact same thing but with a 90-degree angle. And I know that's not perfect, but if I had a 90-degree angle and it was divided into angle C and angle D, I know that angle C plus angle D equals 90 degrees. So if I know either one of these angles, then I can figure out the other one. Same thing here. If I know angle A, then I can figure out angle B. Or if I know angle B, I know angle A. So we're going to continue to expand upon that a little bit. So I want you to go ahead and get out your math journal. And you're actually going to need your math journal and you're going to need a protractor because we're going to be measuring some angles and we're also going to be using this as a straight edge. So once you go ahead and fill out today's date and go ahead and put your heading, I want you to draw this figure. And it may not be exact, but I want you to try to draw it as close as you can, and I want you to label it 90 degrees, 120 degrees, and X degrees. And then when you're finished, come back. Okay, so take a look at this. Now, obviously, we do have a 90-degree angle, but it's not divided into two parts. And we have an obtuse angle, and then we have angle X. There's not a straight angle here, but what I do see is I see an entire rotation or one entire turn. If I took all of these angles and put them together, like if I called this angle A and I called this angle B and I called this angle X, altogether these represent one full turn. So if you can remember back to when we talked about circles and we talked about full turns, one full rotation has how many degrees in it? If you make one full turn, that is how many degrees? Hopefully you said 360 degrees. So underneath your figure, I want you to put 120 degrees plus 90 degrees plus X is equal to 300, and this is an X, is equal to 360 degrees. So this is pretty much like what we did yesterday, except instead of being equal to 180 degrees or 90 degrees, it's equal to 360 degrees. Okay, so let's see if we can solve for X. So the first thing I'm going to do here is I'm going to add these two together. So 120 plus 90 would be 210 degrees plus X equals 360 degrees. Now I added those together by thinking to myself, well, 90 degrees is 10 away from being 100, and 120 plus 100 would be 220, but I had to go back 10 degrees because it was only 90 degrees. Now I've got to figure out what X is. So that means I can take 360 degrees, so X would be equal to 360 degrees minus 210 degrees. I want you to try to figure that out, and then when you think you have it, come back and we'll see if we agree. All right, so if I took away the 200, I'd be left with 160, and if I take away the 10, I'll be left with 50. So this would be 150 degrees. Okay, so far we did not use our protractor, but if you wanted to, you could try to measure that, but the chances of it being exactly 150 degrees are not very good unless you actually measure to make your angles exactly 90 degrees and 120 degrees. All right, so now we're going to use our protractor here, and I'm going to move my protractor out of the way. I want you to use your protractor as a straight edge, and I want you to draw for me two intersecting line segments. So you're going to take your straight edge, it doesn't matter how they intersect, but don't make them perpendicular. I don't want them to intersect at 90 degrees. I just want them to intersect like this. So get two intersecting lines. Now obviously yours are not going to be exactly like mine. So when I go to measure mine, they're not going to be the same as yours. So you're going to have to keep that in mind that we are freestyling here and that your angles are going to be different than mine. But it'll still prove the same point. Okay? All right, so let's go ahead and use your pencil and let's label these. I want you to label yours the exact same as mine. Okay? So I want you to label this angle A, angle B, angle C, and angle D. And then I want you to pause the video and I want you to use your protractor to measure every single one of these angles and then come back. All right? Okay, so I'm going to measure mine, and I want you to keep in mind that mine are not exactly like yours. Here is one thing that will be the same, though. A and C together should equal 180 degrees, or at least very close to it. And A plus D should equal 180 degrees, and D plus B should equal 180 degrees because those are straight angles. All right, so when I measure angle A, I get 130 degrees. So yours probably wasn't 130 degrees. The chances of it being are very slim. All right, so but when I measure 130 degrees, what did you notice when you measured angle B? After you measured angle A and you measured angle B, what did you notice? Let's see if you notice the same thing that I noticed. All right, so let me get mine lined up here. I'm going to flip my protractor. Kind of hard to get this exactly perfectly lined up. Okay, but you can see here that it's not exactly perfect, but if you notice that angle B is very, very close to 130 degrees. As a matter of fact, if I did everything perfect, it would be exactly 130 degrees. Now, if B plus D make a straight angle, that means that this should be 50 degrees and this should be 50 degrees. But I'm going to measure them with my protractor to see if they're similar. Okay? And yes, it is. It's 50 degrees. Okay, because remember, it's acute, so if I go this way, it'd be 50 degrees. Now, again, your angle probably was not 30 and 150 degrees, but what can we learn from this little exercise? Think about this for a second. What can you learn? Hopefully you learned that when you have angles that are adjacent, the opposite angles are equal. So if A is 130 degrees, then B is 130 degrees. If C is 50 degrees, then D is 50 degrees. We're going to use this new skill to help us solve for some unknown angles. All right, so let's go ahead and take a look at our problem set. And remember, if this is a little bit confusing to you, that is okay. Hang in there. We'll work through this together. All right, so let's take a look at number 1. So you can see here that number 1 is composed of this tiny acute angle, and then we have this full turn. So altogether, this has to be equal to 360 degrees because that's how many degrees are in our full turn. So angle D plus 20 degrees equals 360 degrees. So if I subtract these two numbers, that tells me that angle D is 340 degrees. Okay, look at this one. Again, we have one full turn. Now, it doesn't tell us the measurement of this, but we can tell because this symbol tells us what? The symbol tells us that this is 90 degrees. So I have angle C plus 90 degrees equals 360 degrees. So if I subtract these two numbers, it'll tell me angle C. Well, 360 degrees minus 100 degrees is 260 degrees, and I have to add 10 to that because I'm only taking away 90. So C equals 270 degrees. If that doesn't make sense to you, it's perfectly okay to write it out like this. And to use regrouping to subtract, you would come over here and say, okay, this has to become a 2, and this has to become a 16. But I promise you will get 270 degrees. All right, now let's take a look at C. Why don't you try to do C by yourself? And if you get stuck at any point, you can always come back and press play and I'll walk you through it. All right, so first of all, you need to notice that all three of these angles represent a full turn. So I've got 74 degrees. This angle is 90 degrees, I can tell by the symbol. And then I've got angle E, and they equal 360 degrees altogether. If you had these in a different order, it would still be correct. It does not have to be in this order, but 360 does have to be over here all by itself. All right, so now I'm going to add these two together. So I know that 90 and 74 is 164 degrees. So I have to take 164 from 360. Now, I could do this in my head, and here's how I would do that. I would say, well, 360 minus 160 is 200 degrees, but then I still have to take away 4 degrees, so that would give me 196 degrees. Again, you could use regrouping to subtract. That is no problem. You could just come up here, and you would say, okay, well, this is going to be a 5, and this is going to be a 10, and then you have to regroup or decompose again and make this a 5, but I promise you will still get 196 degrees. All right, try to do 4 all by yourself. Do as much of it as you can before you have to come back and work through it with me. But please listen to the entire explanation if you do not get it correct. Okay, so again, I have a full turn, so I know that all this together has to be equal to 360 degrees. So I've got F degrees plus 160 degrees, and then I have this right angle, which is 90 degrees. So I've got 160 degrees plus 90 degrees, which is 250 degrees. When I subtract these two, that gives me 110 degrees, and that would be what F would be equal to. Okay? All right, write an equation and solve for the unknown angles numerically. O is the intersection of line segment AB and line segment CD. Angle DOA is 160 degrees and angle AOC is 20 degrees. So this is like what we just learned in our math journal. Remember what we learned? We learned that opposite angles are equal. So if angle AOD is 160 degrees, then what does that tell us about angle X? Well, it tells us that angle X also has to be 160 degrees. And if angle AOC is 20 degrees, that tells us that angle Y also has to be 20 degrees. This is just like what we learned in our math journal. The opposite angles are equal when you have two intersecting lines or line segments. All right, so let's take a look at this one. They only give us one angle here. Now I know that all of these together are going to equal 360 degrees. So let's think for a minute. What is something that you can figure out? Can you figure out I, H, or G all by yourself? It should be really easy to figure out H, because if O is 125 degrees, then H has to be 125 degrees. We know that right off the bat. Now, these two angles together, I'm going to use my highlighter here to show you, but I'm pretty sure you can figure this out by yourself. But if you'll look, this is a straight angle. Even though that's not straight. Yeah, it straightened itself. Good. That is a straight angle. And what did I learn from the last lesson about straight angles? I learned that these two angles together have to be equal to 180 degrees. So what that tells me is 125 degrees plus angle I has to be equal to 180 degrees. So if I want to find the measurement of angle I, all I have to do is subtract these two numbers. Well, 180 minus 100 gives me 80 degrees, and 80 minus 25 gives me 55 degrees. If that's hard for you to do in your head, again, you can always come over here and write it out. There is no shame in that. Okay, as a matter of fact, you might get it right because it looks like I didn't get it right. No, I did. Okay, so this would be 7 and this would be 10, so this would be 55 degrees. So if I know that angle I is 55 degrees, what does that tell me about angle G? Because they're opposites, it tells me that angle G is also 55 degrees. Okay? All right, let's take a look at angle 7. It gets even more complicated here, doesn't it? So let's just break it down here for a second. Let's try to figure out what can we figure out first. What can we figure out? All right, I've got to figure out K, M, and N. Well, I already know this is 90 degrees, right? 90 degrees. So there's a couple of things that I can do here. I can take a look at this angle. What about this straight angle right here? I know that this angle plus M plus 36 have to be equal to what? If it's a straight angle, what does it have to be equal to? It has to be equal to 180 degrees, right? So I've got 90 degrees plus angle M plus 36 degrees equals 180 degrees. So if I take this 90 and I take this 36 and I add them together, that's 126 degrees plus angle M equals 180 degrees. So if I subtract, I should figure out what M is. So 180 minus 100 is going to give me 80. And then when I take 80 minus 20, that's going to be 60. And I take 6 more away, that gives me 54 degrees. Again, you can always come over here and write it out by yourself. So now I have 54 degrees. Stop for just a second and say to yourself, okay, now I know that M is 54 degrees. Take a look at this for a second. Is there a way to figure out K, or is there a way to figure out O? There's a lot of different ways to do this. What would you do? Well, what I probably would do is there's a couple of things I would do. Well, I know that angle O, and if you look at this really closely, you can see that angle YOX is the opposite of angle WOZ. You see that? Those are opposites. But WOZ has been broken down into two separate angles. So if I put these two angles together, then I should get the measurement of angle N. So I could say 90 plus 54 is 144 degrees, and that would tell me what angle N is. I bet you figured it out a different way, and hopefully you got the same answer as me. If you did not get the same answer as me, and you're not sure why, you could always come and ask me. I'll be glad to explain it to you. If you're at home, you may have to wait until you see me tomorrow. Okay, so we have angle N is 144 degrees. We know this is 36. We know this is 54. And let's take a look at K. Do you see the opposite of K? Well, if this angle is 36 degrees, then K also has to be 36 degrees. Okay? All right, that was a lot of information to take in, a lot of geometry and a lot of measurement and a lot of thinking. If you have any trouble with this, you can always come and ask me. You can always look back to your journal and you can always look back to your problem set to help you.